Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x is equal to 7. Now what I'm first going to do is I'm going to take the log on both sides. So log 5 to the power of x is equal to log 7. Now, an important property of logarithms is, let's say we have log a to the power of b. The power property of logarithms states that we can actually move this exponent here, b, to the front of the logarithm. So then this would equal b times log a. So in this case, log 5 to the power of x, we're actually going to move the x to the front of the logarithm. Because think of x as b. So now this is going to equal 5, or sorry, not 5, x times log 5 is equal to log 7. Now we want to isolate x, so I'm going to divide both sides by log 5 to move it to our right hand side. So now these two cancel out, and I'm left with x is equal to log 7 over log 5, and log 7, this is equal to approximately 0.8451. And log 5, this is equal to approximately 0.6990. So now we have 0.8451 over 0.6990. And now this is equal to 1.2090. So this is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this algebraic equation. So right here, we have 9 to the x root is equal to 243. And we want to find our value of x here. So our first step is to find an alternate way to write 9 to the x root. What's another way we can write this? So we have 9 to the x root, right? Well, remember, let's say we have 5 to the second root. This is the same thing as 5 to the power of 1/2, right? And let's say we have 9 to the 12th root. This is the same thing as saying 9 to the power of 1/12, right? So using this info, 9 to the x root, this is going to be 9 to the power of 1 over x. Because in all those other examples, we put 1 over the root. So now that we have an alternate form of this, well, let's write down our equation. We have 9 to the power of 1 over x equals 243. And now what we want to do is we want to make our bases here the same. We want to make 9 and 243. We want to make those bases the same, equal, so then we could just make our exponent equal and form a simple equation to solve. So what's an alternate form of 9? 9 is equal to 3 to the power of 2. So this is how another way of writing 9, and this is the power of 1 over x. And this equals, well, what's an alternate form of writing 243? Well, 243 is also 3 to the power. Now, we have a pretty simple equation. Let's just simplify this a bit. 3 squared to the power of 1x, this is equal to 3 to the power of 2 times 1 over x. And 2 times 1 over x, this is equal to 2 over x. So this is 3 to the power of 2 over x. So let me write this over here. We have 3 to the power of 2 over x is equal to 3 to the power of 5. And now that both sides of our equation here have the same bases, we could just ignore these bases and focus on our exponents. We could just make our exponents equal each other. Because our bases are the same, our exponents have to be the same. So we're going to write 2 over x equals 5. And now, as you can see, we have a simple equation to solve for x. So now let's multiply by x on both sides. And once we do that, we get 2 equals 5 times x, which is simply 5x. And then now we want to isolate x, so we're going to divide by 5 on both sides. So now we get 2 over 5 equals, these two cancel out, simply x. So x is equal to 2 over 5, and that is our answer.